One of the nitrogen-containing functional groups you will be responsible for identifying is known as an amide. And an amide group occurs when a nitrogen is directly bonded to a carbonyl carbon. So we know that when nitrogen is bonded to carbon, that it could be an amine. However, as soon as you identify a carbon-nitrogen bond, look to see whether any of those carbons bonded to the nitrogen are carbonyl. And if they are, then it is an amide functional group. Now, like amines, we classify amides primary, secondary, and tertiary. If there's one nitrogen carbon bond to that carbonyl carbon, that's known as a primary amine. Secondary amine has two nitrogen carbon bonds, one of which is to the carbonyl carbon. And a tertiary amide has three nitrogen carbon bonds. And again, one of those bonds is directly from the nitrogen to a carbonyl carbon. Now here are two molecules that contain the amide functionality. Acetaminophen, which is a painkiller, it is the active ingredient in Tylenol, and lidocaine, which is an anesthetic. So we see, let's just take a look at the functional groups on acetaminophen. We have this aromatic group, we have a hydroxyl, which is an alcohol, and then here we have a nitrogen. We might think that it is an amine. However, the nitrogen is directly bonded to a carbonyl carbon. So that means it is an amide. And because the nitrogen is bonded to two carbons, it is a secondary amide. Lidocaine also has a nitrogen directly bonded to a carbonyl carbon, so it is an amide, it has an amide functional group, and it's also a secondary amide because that nitrogen is bonded to two carbon atoms. Lidocaine also has an amine group. Here this nitrogen is bonded to three carbon atoms, none of which are carbonyl, so this is a tertiary amine. So this slide here sums up the two nitrogen-containing functional groups, amines and amides, and then further goes over the classification of primary, secondary, and tertiary amines and amides.